In graphing rational functions, you're going to go through a lot of the same steps you've already been doing. You're going to simplify if possible, meaning you're going to factor. Find the y-intercept. Y-intercept is plugging in f of 0, which means setting x equal to 0 and solving. We haven't done that, but it's simple. Find the zeros of the numerator. Well, make sure top equal to 0, zeros of the denominator, bottom equal to 0. Find and sketch any other asymptotes. Plot at least one point between and one point beyond each x-intercept and vertical asymptote, and use smooth curves to complete the graph. Okay, so in words that we've done, simplify if possible. That would mean finding holes. Your y-intercept, set x equal to 0 and solve. Zeros of your numerator give you zeros. Zeros of your denominator give you vertical asymptotes. Find and sketch any other asymptotes. For us, that's going to be our horizontal asymptotes, which had the 3 cases. Plotting points in between, we're going to cover that. And then, of course, connecting all your points. Here is a very simple example, and I've left the steps on the screen so you can follow along. Simplify f if possible. 1 over x minus 3 doesn't simplify. Y-intercept, which means I need to set x equal to 0. So I'm going to have g of x equal to 1 over 0 minus 3, which gives me negative 1/3. On my graph, that means I have my y-intercept at negative 1/3. A little bit below the origin. Zeros of the numerator. Well, there is no x in my numerator, so setting 1 equal to 0 is not going to do anything. My denominator equal to 0 would mean x equals 3. That gives me a vertical asymptote. Any other asymptote, I need to look at my horizontal asymptote. The degree on bottom is bigger, which means I'm looking at y equals 0 as my horizontal. Plot at least one point. So what I want you to see here is that we've created, with our asymptotes, 4 quadrants. Not the 4 quadrants, but we've created 4 quadrants. Top left, top right, bottom left, bottom right. Basically, you want a graph on either side of your vertical asymptote. This one kind of gives us a clue. We know that in the bottom left, our graph has to be in this quadrant. Okay, there's not going to be any graph up here. So what I'm doing is I'm dividing my graph in half on this line. I'm trying to figure out, on this left side, am I graphing above the x-axis or above the horizontal asymptote or below the horizontal asymptote? In this case, it's below, because that's where my y-intercept is. Then I need to test a point on the right side of this asymptote. Okay, what's an x value that's on that side? Let's say 5. So 1 over 5 minus 3, plugging into the original, gives me 1 over 2. That is going to be above. So I know my graph has to look like this. Okay, another one, but this one has a number being subtracted outside the fraction. When I simplify, I want to get this as a common denominator. So I'm going to multiply that 2 by x plus 1 over x plus 1. Now I'm going to have 1, and I'm distributing a negative 2, so minus 2x minus 2 over x plus 1. So negative 2x minus 1 over x plus 1. Plot the y-intercept. So when I plug in x equals 0, I'm going to get y equals negative 1 over 1, which is negative 1. So there's my y-intercept. Find the zeros of the numerator. Negative 2x minus 1 equals 0. Negative 2x equals 1. So x equals negative 1/2. So I know I'm going to cross the x-axis at negative 1/2. Zeros of the denominator. That's going to give me x equals negative 1. So there's a vertical asymptote. Any other asymptotes? Now I'm looking at my horizontal asymptotes. Degree on top is the same as the degree on bottom, so I'm looking at their coefficients. Negative 2 over 1 is negative 2. I need to go down to negative 2. There's another asymptote. Okay, so I have divided my graph again into 4 quadrants. Extend this down here. I need to decide to the left of my vertical asymptote, am I above my horizontal asymptote or below? So what's a value that we could use to plug in? X equals negative 2. And if I plug that in, 1 over x plus 1 minus 2 gives me 1 over negative 1 minus 2, which gives me negative 1 minus 2, which is negative 3. Now, does negative 3 fall above or below? It falls below. So I know my graph has to go somewhere in here. On the right side of my vertical asymptote, I'm already given a hint that everything is above my asymptote because I already have some points plotted up there. Happens to be where my x and my y intercept are at. And there's your graph. Okay, simplify. There is no factoring that can be done. Find and plot the y-intercept. So that's going to be y equals 3 over 1. Again, that's setting your x equal to 0. So y-intercept of 3. Zeros of the numerator. 3 plus 2x equals 0. 2x equals negative 3. X equals negative 3 halves. So I know I have an x-intercept at negative 1.5. Zeros of the denominator, that's going to be x equals negative 1. So there's a vertical asymptote there. Horizontal asymptote right here. Degree on top is the same as the degree on bottom, so y equals, now be careful and pick out your coefficients of x if it was put in order. That'd be 2 over 1, which is 2. So here's that one. And this one I ended up not having to plot points. Whenever you're looking at a section, say we're looking at the left section, I have to be either above or below. I can't be both places. This one has to be below. I already had a point plotted. In this section, I have to be above. There is already a point plotted above. Okay, simplify. This one might be factorable. 3x over, what would that be? X plus 2, x minus 1. So no simplifying, but it does factor, which I can consider that simplifying. Y-intercept, so I'm going to have 0 over 2 times negative 1, so it's going to be 0. So put my y-intercept here. It's also got to be my x-intercept, one of them at least. The zeros of my numerator. 3x equals 0 means x has to equal 0, already on the graph. Zeros of the denominator be negative 2 and positive 1. So I know I'm going to be crossing the x-axis at negative 2 and positive 1. Oh, I'm sorry, not crossing. Those are going to be my vertical asymptotes. Horizontal asymptotes, look at your degree. Bottom is bigger, means y equals 0. And plotting points. So now we've got 3 sections. We've got left, center, and right. That's how I'm going to call them. Okay, in my left, what's a point I can test? -3 is easy to spot. If I plug in -3, I get -9 over -1 times -4. So that's -9/4. So it's going to be negative, which means it has to be below here. In the middle, we have a special one. It's actually crossing the horizontal asymptote, which happens. But we need to figure out which way it's falling. Is it starting up and going down, or is it starting down and going up? Okay, so if I test this point right here, x equals -1, and I plug that in, that'd be -3 over 1 times -2, which is going to be positive. So over here, when x equals 1, I know y equals 3/2. So that's going to be 1.5. So my graph must go like this. Okay, in my right section, I can test x equals 2. So that would be 6 over 4 times 1. So 3/2 again. So when x equals 2, y equals 3/2. So I have to be above this asymptote. So 3 parts. The first left part was below, the middle part went through, and the left part was above. Okay, one more. Simplifying the top, x plus 2 times x minus 2 over x plus 2 and x plus 2. So something different happens here. With 2 common factors, I have a whole at x equals -2, and when I plug in x equals -2, what do I get from that? 0 is what it looks like. Okay, that gives me 0. Plot my y-intercept, so set x equal to 0, means I'm going to get -4 over 4, which gives me -1, so I'm crossing the y-axis at -1. Crossing the x-axis, I've only got x minus 2 left in my numerator. So that is going to be x equals 2. So on my x-axis, I'm going to be crossing at 2. 0's of my denominator. So that means I take x plus 2, set it equal to 0, x equals -2. So here's what's going to happen right now. As we already said, since they had that common factor, it's a whole. But when I come down here, taking the whole out, I still have this left, which gives me a vertical asymptote. And that, you can say, would trump everything else, but trump a whole. So yes, there was a whole, but it also left an identical factor, which puts it back as an asymptote. Horizontal asymptotes, degree on top is the same as the degree on bottom, so we look at their coefficients. 1 over 1 is 1. So a horizontal asymptote at y equals 1. Plotting. All right, I already know I'm going to be down here in this corner because of my 2 points that are plotted. I only need to test my left section. So if I test x equals -3, and I'm going to plug into the factored form, that'd be -1 times -5 over -1 times -1. +5 over +1 is going to be at 5. So I know at x equals -3, I've got to go up to 5, which means my graph has to be on the upper side of these two asymptotes.